Greetings and welcome to GILFORD'S lectures. So today we are going to be deriving the mathematical expression for Newton's law of cooling. And this is the mathematical expression represented here in blue. T of t equals Ts plus T naught minus Ts e to negative kt. So we are going to state the law, and from the statement of the law we are going to derive the mathematical expression. So Newton's law of cooling states that the rate at which the temperature of an object changes is directly proportional to the difference between the temperature of the object and that of the surrounding environment. If T of t is the temperature of the object after t minutes of time and Ts is the temperature of the medium surrounding the object, then mathematically we can say that the derivative of T of t with respect to t is directly proportional to negative into T of t minus Ts. So this is the mathematical expression for this statement above here. So you can express this statement, the statement above, mathematically as what we have in blue here. We will now move into the derivation of the law from this mathematical expression. Okay, so now from the statement of Newton's law of cooling, we were able to bring out this mathematical expression. And the expression below is obtained after we must have rearranged the above expression by removing the proportionality symbol alpha. When the proportionality symbol alpha is removed, then we introduce a proportionality constant k and equate the left hand side to the right hand side. Essentially, when we rearrange the above equation by dividing all through by T of t minus Ts, we obtain this equation below, and integrating both sides of the equation, we obtain ln of t minus Ts equals negative kt plus c, and this c is introduced here because we are dealing with indefinite integrals. Essentially, when we rearrange the above equation, we obtain T of t minus Ts equals e to the negative kt plus c, and T of t equals Ts plus a naught e to the negative kt, where a naught is equals to e to the power c. At time t equals 0, T of 0 is equals to T naught. It therefore implies that T naught minus Ts is equals to a naught. So we have obtained a naught in terms of t, and when we do replace it in the expression for T of t equals Ts plus a naught e to the negative kt, that is this expression, we obtain this new expression, and rearranging the above expression, we obtain this expression below, where Ts is the surrounding temperature, T naught the initial temperature of the object, T of t the final temperature, and K the heating and the cooling constant. So now let us look at a concrete example. The example reads: on a hot day, a cold drink is removed from a refrigerator whose temperature is 10 degrees Celsius and placed in a room whose temperature is 30 degrees Celsius. A. By applying Newton's law of cooling, show that the temperature of the drink at any time t is given by T of t equals 30 minus 20 e to the negative kt, where k is a constant, and that question was allocated 4 marks. And the B part says if the drink attains a temperature of 15 degrees Celsius after 20 minutes, what would be its temperature after 40 minutes? And that question too was allocated for 4 marks. So now let us move straight into the solution. Remember that T naught is the initial temperature of the drink and is given by 10 degrees Celsius, while Ts is the surrounding temperature where the drink finds itself, and it is given by 30 degrees Celsius. And it is clear in the question, since the drink was just removed from the refrigerator, therefore its initial temperature when it is placed in the room, which is its surrounding, is 10 degrees Celsius, and the temperature of the surrounding or that of the room is 30 degrees Celsius. So now from Newton's law of cooling, which says that the temperature of the drink at any time t is equals to the temperature of the surrounding plus the initial temperature of the drink minus the temperature of the surrounding multiplied by e to a negative kt, then we obtain T of t to be equals to 30 plus 10 minus 30 times e to a negative kt. Essentially, T of t is equals to 30 minus 20 e to a negative kt as required. So we have succeeded to obtain the expression that we had in the question. So this expression has been obtained successfully, and that's the reason why we put as required. So we have gained our 4 marks successfully. So now let us look at the B part of the question. Remember that the B part of the question asks you to determine the temperature of the drink at a time t equals 40 minutes, that is at this time t equals 40 minutes, if at the time t equals 20 minutes the temperature of the drink is 15 degrees Celsius. So essentially you just have to replace these quantities you have in the expression obtained while solving the question A, and when you do that you obtain the numerical value of the constant k. When you obtain the numerical value of the constant k, it therefore permits you to use the time t equals 40 minutes and obtain the temperature of the drink at the time t equals 40 minutes. So when you do replace your 15 degrees Celsius in the expression obtained in A, you have this expression here. Essentially, rearranging the above expression, you obtain this expression below, and finally, you obtain k to be 0.0144. So at time t equals 40 minutes, you are looking for the temperature at that time, t of t, which is unknown. Essentially, t of t is equals to 30 minus 20e to the negative 0.0144 times 40. Notice that 0.0144 is the numerical value of the constant k, and t equals 40 minutes is the time for which you wish to determine the temperature. So when you rearrange the above expression, you obtain t of t to be equals to 30 minus 20e to a negative 0.0144 times 40, and finally t of t is equals to 18.8 degrees Celsius. Please, I believe you learned a lot from this video. I believe you loved the video. I believe the video helped you in your calculus skills, in your physics skills, amongst other profitable skills. I therefore urge you to hit the subscribe button, share the video to as many friends as you can, promote the channel, get to me by commenting on the comment section. I will always be available to solve your questions. This is the concours period. You can propose to me questions of ENSTP, propose to me questions of ENSPY, propose to me questions of FED, propose to me questions of any concours of your choice. I'm always available to help you.